Betelgeuse, a massive red supergiant star in the constellation of Orion, is an extraordinary celestial body that has captured the fascination of astronomers and astrophysicists alike for a long time. If it were situated at the center of our solar system, its dimensions would extend far beyond Jupiter's orbit. It shines brighter than the sun. The physical presence of this immense star system is overwhelming, and it is also undergoing significant changes that could lead to a cataclysmic event on an extraordinary scale. Scientists, including renowned experts such as Brian Cox, have expressed concerns about Betelgeuse as it has been sending unusual signals throughout space. These changes have brought about an important question. Could we be close to experiencing a spectacular explosion that could drastically alter the night sky? The mystery of Betelgeuse remains a source of intrigue for the scientific community. Much like living organisms, stars undergo birth, life, and death in ways that often challenge our comprehension. The red supergiant Betelgeuse resides on the outer edge of our galaxy and has been the subject of much interest because of its enormous size and advanced age. Its reddish hue and variable brightness have consistently attracted the attention of both amateur and professional astronomers over the years. Its fluctuating luminosity and color changes have sparked curiosity, but recent happenings have intensified questions regarding its future. As Betelgeuse approaches the end of its life cycle, its sheer size is evident. It is roughly 1,000 times larger than the Sun. So large, in fact, that if it replaced the Sun, its outermost layers would extend far beyond the orbit of Mars, swallowing Mercury, Venus, Earth, and Mars in the process. This tremendous size reflects its current state and its position in the stellar process of evolution. Betelgeuse has exhausted the hydrogen in its core and is currently growing and cooling, indicating its near-term conclusion. It is estimated to be around 8 to 8.5 million years old, which may seem relatively young by human standards, but is ancient in terms of stellar lifespans. Over the course of millions of years, this star has undergone dramatic transformations, evolving from a hot blue star to the cooler red supergiant it is now. These changes have altered the balance between nuclear fusion and gravitational forces, which cause stars to expand and contract throughout their lives. The red color of Betelgeuse is a result of its lower surface temperature compared to hotter stars like the Sun. While the Sun's surface temperature is around 5,500 Kelvin, Betelgeuse's is considerably cooler, around 3,500 Kelvin. This cooler temperature makes Betelgeuse emit light at longer wavelengths, giving it its characteristic red appearance. However, this color change is more than just an aesthetic feature. It provides astronomers with valuable insights into the star's internal processes and ongoing evolution. Betelgeuse's color and brightness have not been consistent over time. Ancient civilizations, such as the Romans and Chinese, once described Betelgeuse as yellow. It wasn't until the 9th century that Arab astronomers observed its shift to red. This color shift marks the star's natural progression from a hotter, younger state to the cooler red giant we see today. In addition to its changing color, Betelgeuse is classified as a variable star, meaning its brightness changes. These changes can occur over both short-term cycles lasting days and longer-term patterns spanning years. The variability in Betelgeuse's luminosity adds to its mystery. Unlike other stars, which exhibit predictable brightness trends, Betelgeuse sometimes deviates from these patterns, suggesting that complex, not yet fully understood processes may be occurring within it. One of the most notable events in recent history was the unexpected dimming of Betelgeuse in 2019, known as the Great Dimming. This unusual phenomenon sent ripples through the scientific community, as Betelgeuse, frequently one of the brightest objects in the night sky, lost much of its brilliance. The brightness declined at a rate of 0.01 magnitudes per day, reaching its dimmest point in February 2020. This drastic change raised many questions about the situation involving the star. One of the challenges in studying Betelgeuse lies in the time it takes for an event and its observation on Earth. Light from Betelgeuse takes more than 725 years to reach our planet, so when we look at the star, we are essentially seeing how it appeared in the past, not as it looks now. This time lag makes it difficult to track rapid changes in the star's behavior, complicating efforts to predict or explain its fluctuations. In response to these unusual observations, scientists like Andrea Dupree from the Harvard Center for Astrophysics have been closely monitoring Betelgeuse using high-tech instruments like the Hubble Space Telescope. These observations have yielded valuable insights into changes occurring in the outer layers of Betelgeuse's atmosphere. As demonstrated by data from the Hubble Space Telescope, Betelgeuse was ejecting material at speeds of up to 200,000 miles per hour, resulting in a dust cloud that partially obscured the surface of the star and contributed to its dimming. This rapid mass loss has led some scientists to speculate that Betelgeuse may be close to a more dramatic event, a supernova. A supernova is the violent death of a star. If Betelgeuse were to reach this stage, its explosion would produce an incredibly bright burst of light, visible even during the day. This event would outshine the full moon and provide a one-of-a-kind opportunity to study the final moments of a massive star's life. Despite the spectacular nature of such an explosion, Betelgeuse's distance from Earth, about 725 light-years, ensures that no direct harm would come from the event. Numerous hypotheses have been proposed to explain Betelgeuse's recent dimming. One is that it marks the beginning of the star's transition to a supernova. Another possibility is that a cloud of dust, formed by the star's persistent material loss, is hindering its light. Some researchers suggest that the dimming could result from changes in Betelgeuse's outer layer or photosphere, possibly due to the formation of a large dark spot on its surface. Regardless of the cause, Betelgeuse's dimming remains a significant area of focus for astronomers. Red supergiants like Betelgeuse are crucial to our understanding of stellar evolution. These stars represent the final stage of a massive star's life before it explodes in a supernova. Their immense size and relatively short lifespans make them ideal subjects for studying the processes that lead to a star's death. Furthermore, the energy released by these stars during their final stages contributes to the formation of heavy elements, which are essential for creating planets and life as we know it. Should Betelgeuse explode, it would provide an exceptional opportunity to observe a supernova from a close distance and play an important part in enriching the interstellar medium with elements that are then incorporated into new stars, planets, and possibly life. The eventual supernova of Betelgeuse could have profound implications for our comprehension of these cosmic occurrences and could provide a dazzling spectacle for astronomers and stargazers around the world. While Betelgeuse's exact fate remains uncertain, astronomers are continuing to monitor it closely, hoping to catch any early signs of a transition into its final explosive phase. Thanks to advancements in telescope technology and space observatories, the scientific community is better equipped than ever to observe and analyze these massive stellar phenomena in real time, or at least as close to real time as light travel allows. What makes Betelgeuse particularly fascinating is not just its potential to go supernova, but also the insights it offers into the life cycles of stars. Its relatively close proximity to Earth makes it an ideal candidate for intensive study, and any significant changes it undergoes could act as a cosmic case study for understanding the mechanisms behind supernovae. Even if Betelgeuse doesn't explode anytime soon, its continued variability and behavior are still valuable to astronomers. It serves as a living laboratory for testing theoretical models of stellar physics, including convection, pulsation, and mass loss. Every new observation refines our understanding of how stars live and die. Public interest in Betelgeuse has also surged in recent years, thanks in part to the media and the allure of witnessing a supernova in our lifetime. If and when it does explode, the event will likely dominate headlines and captivate the imagination of people around the globe. It would not only be a landmark event for science, but also a cultural phenomenon. Until then, Betelgeuse continues its unpredictable journey across the cosmos, glowing with its distinctive red light, a silent but powerful reminder of the universe's scale, mystery, and magnificence. The vast distance from Earth guarantees our protection from any negative effects. Through the study of its dimming and death, Betelgeuse will eventually continue to offer valuable insights into the larger processes that control the evolution of stars. Red supergiants like Betelgeuse offer crucial clues about the nature of the universe's development, as well as their explosive deaths, which contribute significantly to determining the future of stars and galactic systems. As astronomers continue trying to observe Betelgeuse's transformations, the lessons learned from this iconic star will likely offer new perspectives on the larger stellar field as a whole. The study of red supergiants and their eventual fate provides essential information about how massive stars exist and die. By comprehending the mechanisms driving these processes, scientists can make more accurate predictions regarding other stars' life cycles, especially those in similar stages of evolution. The behavior of Betelgeuse may also assist in discovering the enigmatic factors influencing variability in stars. Astronomers are likely to use Betelgeuse as a benchmark for comparison, studying its changes alongside those of other stars to refine models of stellar behavior. The mass loss observed in Betelgeuse offers a glimpse into the extreme circumstances faced by red supergiants. As the star nears the end of its life, its outer layers will likely increase in instability, shedding additional material. Understanding this mass loss is crucial for predicting how other red supergiants will evolve. These cosmic events are not only awe-inspiring, but they are also fundamental to the formation of heavy elements throughout the universe. When a massive star like Betelgeuse explodes, it releases elements such as iron, carbon, and oxygen, the building blocks for new stars, planets, and possibly life. If Betelgeuse were to explode, it would contribute to this cosmic cycle, enriching the interstellar medium and paving the way for new star systems. The supernova's shockwaves can compress nearby gas clouds, triggering the formation of new stars. Radiation released during the explosion can also influence the chemical structure of these new stars and planets. Understanding these processes is essential for our future comprehension of the universe. As Betelgeuse continues to evolve and exhibit unusual behavior, astronomers will intensify their efforts to study it using advanced instruments such as the Hubble Space Telescope and other observatories. These real-time observations will provide crucial data that will improve our models of stellar evolution, especially in the fields of mass loss, brightness variability, and other phenomena that characterize the life cycles of massive stars. In conclusion, the study of Betelgeuse offers an invaluable opportunity to learn more about the life and death of stars, particularly those much larger than our Sun. While our Sun is a medium-sized star with a long lifespan, understanding the behavior of red supergiants like Betelgeuse will allow us to make more accurate predictions about the fate of other massive stars. In addition, insights gained from studying Betelgeuse can deepen our understanding of cosmic forces such as galaxy formation, star clusters, and planetary systems. As we continue to monitor Betelgeuse and other red supergiants, we improve our comprehension of the fundamental processes that govern the universe, helping us answer some of the most profound questions in astronomy. Beyond the excitement surrounding Betelgeuse's potential for a supernova explosion, this star offers a rare look into the final stages of stellar evolution. Its massive size, unpredictable behavior, and impending death provide valuable insights into how stars evolve and eventually perish. The study of Betelgeuse does more than just help us comprehend the complexities of this particular star. It also sheds light on the life cycles of other massive stars and their impact on the cosmos as a whole. As scientists observe Betelgeuse's evolution, they continue to view it as a natural laboratory for studying stellar death. Understanding its transformation into a supernova, should that occur, will help us grasp how other stars of similar size and composition follow the same path. Supernovae are critical events in the life cycle of a star and serve as pivotal moments in the ongoing expansion of the universe. Betelgeuse's behavior, especially its sudden dimming and fluctuating luminosity, offers astronomers an opportunity to refine their models of how red supergiants behave as they approach the end of their lives. Although the exact reason for its recent dimming remains unclear, one thing is certain. Betelgeuse is a key piece of the puzzle in understanding stellar death and the cosmological processes that control it. The substantial mass loss observed in Betelgeuse is another fascinating aspect of its final years. As the star sheds material so quickly, scientists can learn more about the life expectancy and eventual fate of similar stars. This mass loss not only signals the imminent death of Betelgeuse, but also contributes to our comprehension of how red supergiants operate and influence the environments around them. The material ejected by the star will eventually mix into the interstellar medium, influencing the formation of new planets, stars, and other cosmic objects. Astronomers, making use of both ground-based telescopes and space-based observatories, are continuously gathering new data on Betelgeuse. Observations from instruments like the Hubble Space Telescope allow them to acquire a deeper understanding of the star's behavior and internal changes, helping track how stars like Betelgeuse interact with their environments, especially in the final stages of life. These studies also offer new insights into how the rapid mass loss and variable brightness of such stars shape the overall structure of our galaxy. The mass loss from Betelgeuse is of particular interest, as red supergiants like this one expel enormous amounts of material into space, significantly affecting the surrounding interstellar medium. This process adds heavy elements to the medium, enhancing it with the ingredients crucial for the formation of future stars and planetary systems. When these elements are released into space, they become the building blocks for new stars, planets, and perhaps even life itself. As Betelgeuse continues its journey through the subsequent phases of stellar evolution, astronomers are keenly aware that its eventual supernova could trigger the birth of new stars. The explosion would release vast amounts of energy, condensing nearby gas clouds and fostering the formation of new celestial bodies. This is one of the primary ways the universe renews itself, creating the raw materials for the next generation of stars and planets. Although the likelihood of a supernova is exciting, it probably won't pose any direct danger to Earth. The vast distance between our planet and Betelgeuse, approximately 725 light-years, ensures that any harmful radiation or shockwaves would not reach us. Nevertheless, the observational data gathered during this process will continue to provide invaluable information on how stars evolve, die, and contribute to the life cycle of the universe. These findings will help us understand how future stellar events might impact other star systems within our galaxy. As researchers continue to analyze Betelgeuse, they remain focused on a few critical aspects: the mechanisms behind its brightness fluctuations, the rates and patterns of its mass loss, and the internal structural changes that signal its approach to a supernova. Each of these factors plays a vital role in determining the star's timeline and the manner in which it will ultimately explode. Understanding the pre-supernova behavior of Betelgeuse could provide scientists with a warning system for other stars on the brink of collapse. If certain patterns, like dimming, surface pulsations, or increased mass ejection, are consistent among red supergiants, then astronomers might one day be able to predict supernovae before they occur. This would mark a significant advancement in the field of observational astronomy and potentially allow real-time monitoring of these extraordinary cosmic events. Moreover, the importance of Betelgeuse extends beyond stellar physics. Because its death will affect the surrounding interstellar medium, it will also have implications for star-forming regions nearby. The elements produced and expelled during a supernova enrich these regions, creating the next generation of stars with higher metallicity, a trait known to influence planetary formation and habitability. Thus, Betelgeuse's fate may directly or indirectly shape future planetary systems. Instruments such as the James Webb Space Telescope, JWST, and the Extremely Large Telescope, YELT, when fully operational, will further enhance our ability to observe Betelgeuse in multiple wavelengths. Infrared imaging, in particular, will allow astronomers to penetrate the dust clouds surrounding the star, offering a clearer view of its outer layers and the material it expels. Additionally, the study of Betelgeuse encourages collaboration across disciplines, from astrophysics to cosmochemistry and planetary science. As data accumulates, researchers can model the potential paths a red supergiant might take before and after its explosion, including the creation of a neutron star or black hole. These models can be applied across the galaxy to other red supergiants, enhancing our general understanding of stellar end states. One of the most compelling aspects of Betelgeuse's story is the element of unpredictability. Despite all we know, the precise timing and nature of its transformation remain uncertain. This unpredictability mirrors the vast complexity of the cosmos, a universe in which even our most advanced models leave room for awe and discovery. Ultimately, Betelgeuse represents both a mystery and an opportunity. Its eventual death will be a rare and invaluable event for astronomers, one that will provide direct observational evidence of theories developed over decades. Until that moment comes, the star will continue to be watched, studied, and marveled at, a beacon in the night sky and a reminder of the life cycles that govern our universe.